This video is a continuation of my last two videos. Please watch the last two videos in order to understand what's going on in this video. Now, in my last video, Anthony Riley is saying that I am wrong in my analysis because I didn't take perspective into account in this 2D diagram. I should have brought Mount Snaefell down to a small speck because it's very far away. It's 90 miles away. I should have shrunk it according to the laws of perspective. Anthony, we don't use the laws of perspective in 2D diagrams. This is 2D. We have a vertical axis, we have a horizontal axis. We do not have any z-axis. There's no perspective taken into account in 2D. This is 2D. There's no perspective over here. This is 2D. There's no perspective. This is 3D. So yes, we do have perspective. In 3D, we take perspective into account. We can draw lines from the roof, and we can draw lines along the floor, and we can see that the lines converge and there is a vanishing point. So we do have perspective lines. We do have perspective that needs to be taken into account. The back of the house is smaller than the front of the house. So definitely in 3D images, we take perspective into account. However, in 2D, we never take perspective into account. This is a 2D image. I drew a line from the top of the roof. I drew a line on the floor. Can you see the lines don't meet? They don't converge because this is 2D. We don't take perspective into account. There's no perspective lines. No perspective needs to be taken into account. The back of the house is not smaller than the front of the house. The right side of the house is not smaller than the left side of the house. There's no perspective. This is 2D. There's no perspective taken into account in 2D. In this situation, again, no perspective taken into account. Everything is depicted at its correct value, at its absolute value. So Mount Snaefell has to be plotted at its relative size compared to Winterhill and to Blackpool Tower. This is how you correctly draw a 2D diagram, and this is the correct analysis. My experiment over here, which is an experiment which is a 3D experiment of this 2D situation, proves that when the camera at Winterhill is 390 meters high, Mount Snaefell 611 meters high, and Blackpool Tower is 168 meters high, you need 3 Blackpool Towers in order for the line of sight from Winterhill to cross Mount Snaefell. This is exactly what we see in this situation here. The camera was put in the correct position, and this is what happens. We need 3 Blackpool Towers, so this represents Blackpool Tower, and this represents Mount Snaefell. And as you can see over here, when they're next to each other, this is 3.5 times bigger than this. This is 3.5 times bigger than one of these, but because it's 3.5 times further, it looks like the size of one brick. So this is a 3D representation of a 2D diagram. This proves that my analysis of Blackpool Tower, you need 3 Blackpool Towers in order to reach the peak of Mount Snaefell. And the bottom of Mount Snaefell will correspond to this blue line over here. So if the world was flat, this is where the coast of Mount Snaefell would be. This is where the peak of Mount Snaefell would be. Because Mount Snaefell is down here, it proves that this image could not have been taken on a flat Earth. This image must have been taken on a globe Earth. Now, Anthony, when are you going to admit that your insistence that this diagram was incorrect because I didn't take perspective into account was wrong? And when are you going to admit that this analysis proven by this experiment proves that the Earth cannot be flat, it must be round, and my analysis was correct, my diagram was correct, and your insistence that I should have taken perspective into account into this 2D diagram was totally wrong. By the way, Anthony, if you ever get a chance to see my video on sunrise direction, you'll see that the sunrise direction doesn't work in the southern hemisphere, because if you take a date, 22nd of December, from New Zealand, sunrise in New Zealand on the 22nd of December, it's midday in South America at the same time. But people in New Zealand do not look northeast to see the sunrise. They look southeast to see the sunrise on the 22nd of December. How is it possible that people in New Zealand look southeast to see the sunrise when at the very same moment the sun is right overhead in South America. This cannot be explained on a flat Earth. Please see my video on this topic.